So what do you think? What is it about empirical rule? Who remembers what empirical rule states?
Only applies to normal distribution.
Only applies to normal. I like it.
I think there's 6 to 8% in one.
Good. Within one standard deviation, there is 68% of the data. It's a lot less ambiguous than Chubby-David's rule, right? Or Chevy-Chev. 68% in one, 95% in two,
99.7.
99.7 in three. Cool. I like it. And they're just three numbers, but I want them to be more than that. Why does it make sense that there's a big old chunk right in the middle? Because of the shape of the curve, right? Most of the data is in the middle. And it's just because it's specifically a normal curve. A normal curve must follow that rule. It's got to start low, go high, and go low, but now we have a much more precise definition. There must be about 68%. We can say it's close to normal if there's about 68% within one, well, 95% within two, 99% within three. We could say it's roughly normal. We can do all this other stuff with it. You guys decently with me? So how does that apply to this specific problem? What do they tell me? They tell me the mean is what do they tell me?
12.
125. And what else do I need to know?
Standard deviation of 0.
Standard deviation is
0.3. 0.3.
0.3. Cool. So what's one step up? What's one step down?
Minus 12.5.
124.7. Cool. So far so good. What's one more step up? 125.6. Incredibly enough. What's one more step down? Sweet. Do we see anything they're talking about here yet? Look at part A. What's part A ask? Yeah, what's the approximate percentage of voltage amounts between 124.4 and 125.6? Kick ass. And that's, yeah, exactly. You kind of do for yourself this, and I kind of want you to do this to get used to doing this. This is going to become big in chapter 6. But for right now, we just know this one rule with these three numbers. They have to give me now in chapter 6, we're going to expand on this. Because what did they said in between 125.1 and 125.7? Can empirical do anything for me there? No. I wasn't lucky enough for it to land right on top of one of these. So empirical rule is limited. It can only say within exactly 1, within exactly 2, within exactly 3. So if my number is not exactly one of those, I can only give a really rough approximation. So chapter 6 gives us a way to figure out exactly what that is. Cool? Semi-decent? So part A says from there to there. Well, that's 2 standard deviations out. So 95%. What's part B say? So I got to go one more out, right? One more down would be 124.1. You guys cool with that?
Yes.
Because they've established every step I take is 0.3 big. And one more step up. 125.9, which incredibly enough are exactly the numbers they asked me there. So they have to be very precise here. In chapter 6 they can give you whatever the hell they want to, because we'll have a better way to figure out more precise stuff. So part B, what's within 3? 99.7%. Sweet. Yeah.
Is it 95 or 94?
95.
95.
Definitely 95. Let me come off of it. Let me make my own part C. Here's Jeff's C. Let me see what you guys think. What percentage is above 125.6? Don't say anything out loud. Some of you guys want to say, what the hell, I don't know. What percentage is above? I mean, let me put this in a different way. So I'm asking what percentage above 125.6? Another way to say that is percentage of the variables above 125.6. Do you see that's the kind of the mathish way to say the same thing? So take a minute and think about it. You can actually answer this question. Because it is one of the numbers that's up here. It's not in between things, is it?
Above. It's above.
But you can reason this out. You can't.
Or don't you have to like subtract?
You have to do something like that. Some of you guys are just staring at me, waiting.
Is it like 4.7? 4.7? No?
2.5.
Like 2.5, yeah.
Where did that come from? That sounds intriguing. I see where yours came from now. I didn't at first, but now I know where you got yours. You got to be careful about you kind of went the wrong way, and you'll see in a minute why. How much is in here? We already said that, right? How much is in here? 95. Which means how much is outside of there?
2.5.
So how much is on that side?
5.
2.5. See, that's the kind of thing you can do right now. You can play with these numbers. So they're just 3 numbers for you to memorize, but I can ask you, and you know I will. I can ask you questions like, what percentage is below this? Right? Well, so this one wasn't that bad. There's 95 in here. There must be 5% outside. Is everybody cool with that? Obviously, there's 95% in there. There must be 5% out there. There must be 2.5 out there. How do I know to cut it directly in half? Because this is symmetric. It's normal, which is symmetric. So there's 2.5% there. Yeah.
So looking at the empirical rule, how is it 99.7%? Because it shows 2.4% going past to 3 standard deviations for the empirical
Oh yeah.
rule.
So let's figure out where they at 2 and 3. So they do it from here to here, right? So how in the world could I figure that out? They just do it right in there, right? 2.4% specifically in there. And that's because
They counted. Huh?
how much is out here? It's the same question I just asked you, right? How much is out here was 2.5 because there's 95, 5, cut in half, 2.5. Well, how much is out here? How much is in between there?
0.3?
Well, okay, there's 99.7 in there. So there must be how much outside? 0.3, so there must be how much on that side?
0.15.
0.15, so for some reason they rounded it to 0.1.
Yeah,
Because they actually, yeah.
they show 2.4%, not 2.5.
Because if this is 0.1%, then how much is, and this is 2.5% all the way, how much is just in here? 2.4%. That's where it comes from. So there's a lot of playing around. I'm not going to get like uber detailed like that.
Yeah.
But I will ask you questions like what percentage is below this? What percentage is above that?
Just because the math equals 99.8%, is why I was confused for part C,
Yeah.
not 0.7. Because it's 2.4 added into the 95 plus 2.4, so it would be 99.8%. Unless they're doing some kind of rounding or something.
No, so 95 plus
2.4
4.8.
plus 2.8.
Yeah.
So it would be 99.
Oh yeah, there's definitely rounding in here, obviously.
Okay.
Right. Yeah.
So is there a reason to just say it's 99.7%? Like
Because that's true.
Okay.
And they rounded on this picture, so be careful. I like that you're trying to piece it back together to verify this, but they rounded those numbers a little more than these are. Cool. All right. Just know. Okay. All right. Is everybody semi with me? So let's do one more example. What percentage? I keep saying this. What percentage is below 124.7?
Below.
Yeah, because how much is in here? 68%. So how much is outside? 32. So how much is on that side? 16. Is everybody semi seeing what's going on here? So I will ask you basically exactly that kind of question. I'll give you some mean and I'll give you some standard deviation, so you can always set this up, right? And then you can answer whatever the hell question I throw at you about those numbers. Cool. Sweet. So this was 2.5%. And probably X was less than 124.7, less 16%. Okay, cool. All right.
When it asks 12.4 volts and 12 into 5.6 volts, does that mean in between?
Yep, exactly. In between 124.4 and 125.6. They ask you in the question itself, what is the approximate percentage of voltage amounts between blah, blah, right? They say between. In the question itself, it says between.
So
Between
yes.
124.4 and 125.6. So that's the 95%. Because the empirical rule says within 2 standard deviations, so between 2 down and 2 up is 95%. Okay. Sweet. All right. Any other questions from homework? Yeah.
Number 4, 3, 3.
Oh, cool. Perfect. What did we say? I think this is one of the last things we did. What did we set up as for right now meaning unusual? More than 2 steps away, right? Either direction. So more than 2 up or less than negative 2 down. Cool. So in this problem, they say
Number
3.
4, yeah.
4.
What's that, sorry?
You put here 3.
Oh, of course I did. 4. 40 women, they have a mean of 110.8 and a standard deviation of 17.1, which is a sample size. The highest blood pressure measurement in the sample is 181 millimeters of hemoglobin. Is this an unusual measurement given that the data has values of this?
Yeah.
How do you figure that out?
The standard deviation only it can be like 6 standard deviations away.
All right, so be much more specific. How can you be much more specific? You got the right idea, but I want you to get used to.
Drawing the line.
But I like that because we just did that. But I want the exact number now, right?
Number.
How many standard deviations is that away from that? And what measures that? Z-score, 11. Z-score is that. So what would the Z-score be for this case?
181.
Good. My data point minus the mean divided by standard deviation. Cool. So if you do that, you get something.
4.10.
4.10?
Yeah, that's the Z-score.
And that's obviously more than 2. So then the answer to this would be, since the Z-score is higher than 2, it is unusual. This would be a bad sign for somebody. Yeah?
Now, if it were 2, is that unusual or usual?
If it's exactly 2, that's a good question. And it depends on the book. I can't remember this book. Exactly 2, I think this book says exactly 2 is unusual. I can't remember where this was.
It's greater than 2.
Greater than 2?
So,
Okay.
yeah.
Every other book I use says a different thing, so exactly 2 by this book would be usual. Now, let me say a quick word about that. And I tried to say this earlier. What's unusual we're considering to be more than 2 right now. Because later we're going to have different values for what's unusual. Because in different situations, something should be considered. You know, if I'm walking through, there's a killer in the house, I'm going to be very heightened. Unusual is going to suddenly become very much closer. Any creak I hear is suddenly, ah! Whereas if I'm just coming to my house or with my friends and we hear a creak, we're like, what the hell? No big deal. And of course, that's when we die. But are you guys semi with me? So depending on the situation, we as humans already do this. We don't do this mathematically. We just kind of, that would have been fine before, but now that I'm scared, it's unusual. I suddenly changed my definition of what's unusual. So mathematically, we can do the same thing. It doesn't always have to be 2. If it's bad to make a mistake, remember about proving something or disproving something? If it's bad to make a certain mistake, I can move that around, make it 3 or make it 1. Cool. But for right now, more than 2 is considered unusual because that's actually what we do most of the time. Okay, cool. All right. So there's no other questions. We're going to finish out chapter 3. Anybody taken the SATs recently? Oh, sorry.
So with if it equals 2, then is that still?
If it equals 2 by this book, that's usual. It's got to be more than 2. So if it came out to be exactly 2, you'd say that's not unusual.
So it's equal
Yeah, but my purpose for going on that side note about later we can change it is, it's totally subjective. It depends on your situation. So 3 could be usual, depending on the situation. 1.5 could be freaking unusual, depending on the situation. So let me say it again. Has anybody taken the SATs anytime
Or
at all in your life?
Yes.
Yes. Do you remember when you got your score reports? What do they actually give you? Do they tell you you got a 90?
They give you a bunch of, each little section, they divide it up.
And what do they give you? Do you remember they give you the scale?
Yeah.
And do they still put a little X where you are?
Yeah.
That's the same thing they do with me. But they give you, I don't know if you guys remember the name of this, they tell you what percentile you're in, right? So if you get an 80th percentile, does not mean you made an 80% of the test. That does not mean you got 80% of the questions right. Did you know that?
80% of people, right?
Beautiful. So a percentile, for example, 80th percentile. All right. Now you know that's too many, it's too long of a thing for a math person to write, so we write that as P80. There you go. P80, if P80 is something, that means that 80% of the people scored below you. So if you got an 80th percentile on reading, 80% of the people that took that test got a lower score than you did. How are we doing? Is that understood? And the reason they do that is anytime they change the SAT, it would be a little evil if they gave you an absolute score and they just randomly happen to make it easier SAT. So you take it one week and the next week it's an easier one, and your buddy gets the higher score, like, oh, you're stupid. But you guys, so they want to do it relative to that test. So if they happen to make it easier SAT overall, everybody does better. You have the same percentile as you would have done. You with me? Because if everybody does a little better, you're going to be in the same relative place, according to them. Okay, how are we doing so far? A little bit. So, with that idea in mind, and with a little caveat, the smaller the sample, the less sense these things make. If my sample is 2 numbers big, what's the 80th percentile? What's the 70th percentile? What's the 59.3rd percentile? I mean, my God, I can't get that precise with only 2 numbers. So I'm going to throw 10 numbers up here, just to make it simple. Understanding that the more specific percentiles make more sense with a bigger sample. You with me? So I just want to put 10 numbers up here. That's enough for right now, just to get the idea. So let's see. How many numbers is that? 5, 6, 7, 8, 9, 10. Okay. So somebody give me a guess. Go ahead and write those down. As you're writing, think about what might the 80th percentile score be?
27.
Okay, so one guess. It's 27.
26.
Why do you guess that? Real quick.
It's the 8th one.
I like it. That makes sense. Any other guess?
29.
29. Why do you say that?
Because it's more, because it's the 9th one, so it's more than the 8th one.
All right, good. So this is because it's the 8th one. This because it's the next one up from the 8th one. So
you do better than everything.
yeah, good. All right, all right. Yeah.
28.
All right, I got a guess for 28. I don't even see 28 up there. Why do you say 28?
The average between the.
All right. So we got 3 different ideas, and they're basically all kind of hovering around each other a little bit here, right? So here, this this makes sense to me as a first guess, because how many, exactly the way you said it, how many numbers are below 29? 8 numbers are below it. And what's a percentile? 80th percentile is supposed to have how much of the data below it? 80%. And 8 out of 10 is 80%. Now the problem is, how much is it supposed to have above it? 20%. How many does it have above it? 10%, right? 1 out of 10, you guys with me? So then, of course, you get the same problem with that number. You get the right number above it, but not the right number below it. So it sort of feels like median, right? Doesn't it? If there's an even number of things, there is no middle number. There is no number that has half of the data above and below it. So you have to average those two to make it happen. So there is no number that has 8 numbers below it and 2 numbers above it. So you have to make it. So that's why 28 is right. I love it. Cool. You have to average those two. So how many numbers are below 28? 8 out of 10 is 80%. Above, 2 out of 10 is 20%. Beautiful. It's right in the right place. How are we doing so far? So, thinking about that, what I just said, median is a specific example of this. What percentile is the median, of course? 50th percentile, right? Because it's got half the stuff below it and half the stuff above it. Okay. So here's the general way to find percentile. And I like the first guess was 8, and I'm with you on that, because if I want to get to the 80th percentile, how far into the list do I want to go? 80% of the way in. And 80% of 10 is 8. So it's an excellent first guess. So just go in that far, that should be it. But now we see there's a little bit of more to it. So here's the 2-step process for percentiles. So the first step is just like we just said. If I want the, I don't want to freak you guys out with too many variables. So let me give you an example to show you the steps. If I want the 70th percentile, and there are, let's say, oh, what, Jeff? I don't know. 100 data points. And then you take 70% of 100. So 0.7 times 100, of course, is 70. So this will feel a lot like the median, though. When it comes out to a whole number, you average that with the next one. That kind of jives with this. 80% of 10 is 8. I average that with the next one. That would give me the right answer.
But that's only if it's even.
Only if it's a whole number.
What if it were, 101 or something?
We'll do that in a second. Step 2, now don't just circle this. What does step 1 tell you? It tells you where the answer is. So don't forget step 2, go get the answer. Right? I hate when people circle this. That's my answer. No, that you gotta go to the 70th number and give me that. Right? Go get the answer. In this case, P70 is the 70th number. In this case, it's not always the 70th number, is it? Obviously, you're not always going to have 70 numbers, so that doesn't even make sense. It's the 70% of the way in. Now, what did I just do? Jeff, you almost got it. 70th number averaged with the 71st number. Okay, cool. Because if it comes out to a whole number, you have to average that one with the next one. Okay. I got too involved in trying to figure out how to say that second step. So, like you said, what if it doesn't come out that way? So if it's a whole number, you average that with the next one. Anything else, you round up and take that number. Yes, sir?
What do you mean by that? Is that it?
I'll do it again.
Okay.
If it's a whole number, you round that with the next one. So if I came out with 6, I would round the 6th number with the 7th number. With me? If it's anything else, 6.2, 7.8, whatever, I round to the next number up and take that one. So let's do some specific examples. Let's say I have 248 data points. And we want P75. How do you figure out which number is going to be the answer? What's the first step?
Multiply.
Multiply what?
0.75 with 248.
Yeah, 0.75 times 248. I want to go 75% of the way into the list. 186. $186. So if it comes out to a whole number, what do I do? You average that with the next one. So I want to average the 186th and 187th numbers. Right? That would be my answer. But if I want P, I don't know, P23, do that one. What would P23, what are the two steps give you?
57.04.
Yeah, so first step, you do 0.23 times 248. What are you getting?
57.04.
57.04. So which number is going to be the answer? I'm sorry, say again? 58. Period. You always just round up. If it's not a whole number, you take the next one up. So that's 57.04. Closer to 57. I don't care. Round up to 58. Get the 58th number. Okay, cool. Let's do one more example, a little more concrete than that. Obviously, in this one, I don't have any data points. Right? So let's do one more example with some data points. Let's do it out of the book. So you just stare at me making numbers up. One that's in order would be nice. Notice, obviously, just like median, these numbers have to be in order for the answer to make sense. Yeah.
On the second step, number 2, go get the.
Answer, yeah.
Oh.
Wow, that was a really good. Get the answer. Go get the. We're not sure. Just go get it.
No problem. Thank you.
Okay. Let's see. Do they have anything that's in order? Yes. Look at page 128, number 29. I know the instructions ask for something else, but I don't care. We're just going to use the data. If you are the booklets out there, yes.
Does step number 2 mean get the average that we're looking at and 59, or just get the 58?
No, get the 58th number. Period. Exactly. So the only time you're going to average is if it comes out to be a whole number.
Oh.
And think about it, median. If I had 4 numbers, so it's half of 4. So, but is the second number the answer? No, I average it with the next one. So the median is a specific example of a percentile. They should work the same, right? What's half of 5? 2.5. It's not a whole number, is it? So I round it up. So the third number is the answer. Hey, holy shit, it's the same thing we do with median, right? So the median is a specific example of percentile. It has to operate the same way. And it does. It's just 50%, so that's why it's an easier way to do it in general. So number 29, it gives you a list of data. If you don't have a book, you can play along to a point here. So my question, I'm not going to ask the same question they do because we don't know what a box plot is yet. My question would be, what's P25? And then I'll ask a second question. What is P 81? So let me tell the booklets out there, there are 1, 2, 3, 4, 5, 6. You do it 12? N is 12. So even if you're booklets, you can still work it out to a certain point.
0.25 times 12.
Yeah. P25 is not too bad, and it's a quarter of the way through. There's 12 data points. You don't really even have to set it up, but just for fun, it would look like that.
3.
Yeah, so it's 3. It came out to a whole number, so where's the answer?
3 plus 4.
Yeah, third and fourth averaged, right? So step B, the third number, fourth number. If I average those, 708?
706.
6. Oh, it's off. Wait, that's right. How are we doing so far? So 706 is the number that has, that's what? Be more specific.
Percentile.
It has 25% of the data below it. Cool. Okay. Exciting. What about P81?
9.73.
9.73? Yes, sir.
9.72.
To go back to the, that one, wouldn't 705 and 707 also have 25 below them?
Exactly. So, if you start really thinking about this, small sets of